Good morning, good afternoon, or good evening. This is Mr. P coming at you again here with our Honors Secondary Math 2 guided notes for section 13.9 parabolas. So previously we learned that the graph of a quadratic function is a parabola that opens up or down. A parabola can also be defined as the set of all points x, y in the plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. That is, a parabola is all the points so that the distance from your focus, which is some point on the axis of symmetry, is equally distant to the what's called the directrix, which is this other line here. That's the idea. So the standard equations of a parabola with a vertex at the origin, there's vertical types where the x is 0, where x equals 0 is the axis of symmetry. These are the types that we've been doing before, that their equation is y equals 1 over 4p times x squared, where p is the y value of the focus, the y value of where the focus is sitting. The focus is at 0, p, and the directrix is at y equals negative p. You could also think of that as how to find it there. Okay. Now, if p is greater than 0, it looks like this, where the focus is up here and the directrix is down here, or the focus could be down here if p is less than 0, and then the directrix is up here. So, but it turns out the same is true for horizontal axis of symmetry, where y equals 0, where the only difference here is the equation is 1 over 4p times y squared, where p is now the x value of the focus. And the directrix is at x equals negative p. It's now a vertical line. So let's look at this guy. So in order to write the equation for this, first we have to decide if this is a vertical or a horizontal axis of symmetry. And the axis of symmetry is vertical, so this is going to have the form y equals 1 over 4p x squared. And that was just something that we have up here. Now the focus is right here at 0, 5, which means 5 is what p is. You can't see it, but the directrix would be down here at y equals negative 5. Something like that. It would be way down here because it has to be equally distant. The vertex is part of that. It's equally distant from the focus and the directrix. So that means that this is y equals 1 over 4 times negative 5 x squared. Now 4 times negative 5 is negative 20. So I would say this is 1 over negative 20 x squared, or I would prefer to look at it as y equals negative x squared over 20, where the negative, I like to see the negative sitting outside. Just pop that up there. Very good. And that's all there is to it. Okay. Now this one has a horizontal axis of symmetry, which means it's going to take the form x equals 1 over 4p y squared. Now p, we can't see the focus, but remember, the directrix is at x equals negative p, and since it's at x equals negative 7/12, the focus we're assuming is also at 7/12, at 7/12, 0. So that is x equals 1 over 4 times positive 7/12 y squared. Now, why positive? Because the directrix has the negative value, the focus is going to have the positive. 4 times 7/12, so cross divide, that's 3 7/3. So x equals 1 over 7/3 y squared. But if you divide if you divide 1 by a fraction, then it's going to become y equals 3/7 y squared, right? Keep, flip, multiply. Cool. Identifying parts of the parabola. Identify the focus, directrix, and axis of symmetry of the parabola, then graph the equation. So remember, what we're saying here is x squared equals negative 2y. That's weird. So we have to solve that so it's y equals something, since x is the part we're squaring. Divide both sides by negative 2, and I think this will make a little bit more sense if we say this is y equals 1 over negative 2 x squared. Now, why am I doing this? Because the form it's supposed to have is 1 over 4p x squared. So I know that negative 2, the denominator of that fraction, is equal to 4p. So if I divide both sides by 4, I get p equals negative 1/2, which means the focus is at the point, let's see here, it's x squared, so it's vertical axis there. So it's the focus is at 0, negative 1/2. I'm going to go ahead and graph that. Oh no, that's okay. Wait, no, that's 1. See how they're counting funny here? Why on earth would they do this to me? So awful. Please write Granite District. I'm just kidding. Don't actually write Granite District. I like these notes. Just sometimes these are not the decisions I would have made. Because see, that's 1, 2, 3, 4. So I need negative 1/2. So I actually need to split that into halves. Boo, boo. Now, let's see here. So that means that the focus is at 0, negative 1/2, which means the directrix is the line y equals positive 1/2. Ooh, that was pretty good, Mr. P. Why, thank you. I try. So what you're going to do to actually graph the axis of symmetry, the axis of symmetry, I'm sure you noticed, is the y-axis. This guy. And so the vertex is going to be here at 0, 0, because that's halfway between, let's see, can I get a different color? Pink. Halfway between 1/2 and negative 1/2. Now, as this is going to bend away like this because other points on here are going to be equally distant from the directrix and the focus. And so these always bend away from the directrix because it could never touch the directrix, right? Like if it went like this, that's not possible because then the distance to the directrix would be 0, and so it couldn't be equally distant from the directrix and the focus. So it bends away. Ooh, sorry about that. So it bends away from your directrix.